In this video, I'll be making an articulating dustarm for my shop, with quick connect magnetic clips and some more features you're not going to want to miss. I started this project by making some sketches, then modeling the silhouette out in CAD. This allowed me to print out a 2-scale template and make the process so much easier. I could then begin breaking down the plywood I'll be using for the project. The entire project is made out of scrap 1/2-inch plywood, and I'm cutting it down to 4 feet, which is the length of each segment of the arm. I can then use the template to mark out where I'll be getting both pieces from and cut a slightly oversized rectangle out on the table saw. I can then take another scrap piece of wood, making sure it's larger than the board I just cut, and rip a fresh edge off it on the table saw. This will be used as a sled, and so I won't touch the fence after the cut. I then add some double-sided tape to the back of the plywood, and line up the marks I made before to the edge of the sled and stick the plywood down. This will cut the plywood into 2 trapezoids with a matching complementary angle. Then by flipping one piece around, I can mark where to cut the oversized piece down to match. But since it's a trapezoid, there isn't a flat edge to run along the table saw fence anymore. In this case, the end I want to cut is very close to the fence and could get stuck in the throat plate. So instead, I'll use the complementary angled pieces and tape them back together here to get a rectangular board again. Now I can start taping my template down to my workpieces. I do wish I had some spray adhesive for this application, but I couldn't find mine, and this worked well enough. I then drilled some holes and used the jigsaw to remove most of the material of the pattern I needed to cut out, making sure to always stay slightly proud of the line when cutting, since I would be using a router and sander to refine the shapes down. As for these corners, I just nibbled away as much as I could do slowly. Being quite proud of the line in other areas wasn't too much of a concern, but these inside corners would be a pain to clean up later. This is because I'd be template routing most of the part, but wouldn't be able to reach these inside corners. Speaking of template routing, I could then set up my template for routing by clamping and double-sided taping down a series of straight edges along the lines of the paper template. Most of these were made of plywood offcuts, and the only thing to really keep in mind here is that the pieces have to be the same thickness. I'm installing a 3/4 inch templating bit into my router here. If you're unfamiliar as to what a templating bit is, essentially it has a bearing and a cutter, which are directly in line with one another so that the bearing can ride along the template and copy the shape. In this case, it's riding along the scraps that I had taped down to the workpiece. All I have to do is make sure I don't cut too far into the large curves. I can then bring it over to the router table where I can finish the cut with a flush trim bit. I then use a spindle sander to finalize these inside curves. This is why I tried to remove as much material as possible with the jigsaw earlier. The larger curves couldn't be cut with the router, so sanding will clean these up as well. And remember when I said I just needed to make sure not to route too far into the curves? Well, I was speeding through the process and did it anyway on one of them. Luckily, it was a pretty simple fix. Just cut some scrap to fill in the patch, glue it in, and sand and route it flush. With a coat of paint nobody will ever notice. And with all that done, all I need to do is do it all over again for the other piece. Next, I would be working on where the vacuum and dust separator would live. This corner of my shop has been filled with scrap and gardening tools for years, but with a little cleanup it was ready for some shelving. Now, I won't be going into too much detail on this section since it's pretty specific to my space. But basically, I used some scrap wood from the corner to build a couple of shelves to hold the vacuum and dust separator in line vertically. And the entire frame was made very simply with just screws and butt joints. I just made sure to use referential measurements whenever I could, and it ended up being a pretty nice fit. Here I'm using some scraps as spacers so I don't have to try and level this frame in such a tight corner. And then I can just screw into the studs. With all that done, all that was needed is a fresh coat of paint. hardware, I just used some standard door hinges, but I decided to drill out the holes slightly to 5/16 on one of them so I could use bolts instead of screws. This over time will lead to less deformation at the joint since the 1/2-inch plywood isn't thick enough to yield a solid screw joint. Then using double-sided tape to stick the hinge in place, I drilled center marks where all the holes would go, and then drilled all the way through. It was finally time to run the piping along the ceiling. I used 2-inch ABS tubing from the hardware store and cut it down to size all on the miter saw. The way I'll be attaching these to the ceiling is by using these 3D printed parts I designed. They have a stop dovetail and a matching groove, which allows the pieces to easily attach and detach for installation, which as you can see comes in very handy since I'm in a pretty precarious spot trying to balance everything during install. I used two 45-degree bends instead of a 90 here, which does make the math harder, but it provides far less resistance and airflow, so it is worth the extra effort. Then disassembling the two sides of the arm, I can pre-drill the screws into the plate so I don't have to scramble for them in the air, just making everything far smoother. Finally, I could bolt on the second part of the arm, and it didn't work. So when I modeled this in CAD, I modeled it straight, so in my head, all the force was directly down here. But as the arm folds, the force is applied over here, and compounded with the fact that this entire thing is a massive lever, causes a huge rotational force on the center beam. So I had to take the whole thing down and redesign. My new plan was to build a box around the centerpiece, which would hopefully resist the rotational force and keep everything in line. The construction of this was very similar to before, cut out some trapezoids, just notching a little bit to have everything flush, then a quick sanding and paint job before I could sand the paint off where the joints would be, and then some glue and screws, and everything was assembled. With that done, I could finally try attaching the second arm again, and it actually worked this time. So I could hook up the rest of the flex hose, which started by cutting into a Home Depot bucket to attach to the cyclone separator. If you don't know what that is, it's a cone which runs between the vacuum and the dust that catches the dust and drops it into a bucket before it gets to the vacuum itself. This makes cleanup and emptying much easier. I then hooked up the vacuum cord to this plug, which I can remotely turn on and off with a remote from anywhere in the shop. Then it was on to the simple task of zip tying the flex hose onto the dust arm. And quick tip, If you don't have zip ties long enough like I didn't, just feed 2 of them together and make it longer. The last thing to do was install some more 3D printed parts, and I printed a whole lot of parts. I had tried some designs with chunky bodies and even the swiveling mechanisms, but due to weight concerns reverted back to simplicity with this design. These 2 parts indexed together. Then, by marking all of one side on the stack of magnets, I could pair them into 3s. The markings made sure I had the pull directions correct before gluing everything together. Then, I could slide these parts over the hose, and using a captive nut and bolt, tighten down the clamping mechanisms onto the hose. The corresponding parts just press fit on top of the arm, got held in place with some screws, and with that, the build was finished. Even with the struggles, this project was a ton of fun to make and will be super helpful in the shop going forward. The end of the hose connects straight up to all of my tools with the 2.5-inch port, and as for my tools with weirdly shaped connectors, I can just 3D print adapters. I hope you found this video enjoyable, maybe even learned something, but most importantly, thank you so much for watching.